Last time, we talked about permutation where the arrangement of objects matters. Today, we will talk about combination of objects. A combination is a computing technique that determines the number of possible selections in a collection of items, where the order of the selection does not matter. Yes, arrangement or order doesn't matter. For example, suppose you're assigned by your teacher to be the leader of your group for your group project. You were given the freedom to choose 4 out of your 13 classmates to be your group mates. If you choose Don, Mindy, Gala, and Stephen, does it make any difference if you choose instead Stephen, Mindy, Don, and Gala? Of course not, because the list refers to the same people. On the other hand, if you choose Stephen, Mindy, Don, and Vina, now that is another grouping, because it is different from the first grouping cited. Each selection that you could possibly make is called a combination. By definition, let R be a non-negative integer. By a combination of a group S of n objects, we understand an unordered selection of R of the n objects of S. In other words, a combination of S is a subgroup of S consisting of R of the n objects of S. Say S is equal to the set ABCD. Then the groups ABC, ABD, ACD, and BCD are the 4 combinations of S. If we are to choose 3 objects from the 4 objects of S, these are few representations or notations that mathematicians use to represent combination, but we are going to use the first one. We usually say the combination of n objects taken are at a time. The combination of group S is given by n factorial over r factorial times n minus r factorial, such that n is greater than or equal to r, where n is the total number of elements in a set and r being the number of selected objects. Let's have some example. Suppose you are asked to form different triangles out of 4 points plotted, say ABCD, of which no 3 are collinear. You can see that triangle BCD is the same as triangle CDB and triangle DBC. In the same manner, triangle ABC is the same as triangle CBA and triangle BAC. The different triangles that can be formed are triangle ABC, triangle ABD, triangle BCD, and triangle CDA. Thus, there are 4 combinations. The other triangles are just the permutations of the 4 groups. Using the equation, we have the combination of 4 taken 3 at a time is equal to 4 factorial over 3 factorial times 4 minus 3 factorial. Expanding this, we have 4 times 3 times 2 times 1 divided by 3 times 2 times 1. You can see that we can cancel out 3 times 2 times 1 and we are left with 4. Therefore, we have 4 possible triangles.